Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the introduction to vibrations, free and forced vibrations, simple harmonic motion, and important terms. The outcome of today's session would be compute the time period and frequencies of simple, compound, and torsional pendulums using the basics of free and forced vibrations. The topic covered would be introduction to vibrations, free and forced vibrations, simple harmonic motion, and important terms. The topic learning outcome is understand the concept of free and forced vibrations with simple harmonic motion and apply them to field problems. First, let us see the introduction of the vibrations. Vibration is a periodic motion which repeats itself after a definite interval of time. So, the movement of any object that repeats itself, that means in a to and fro motion. If the object is moving to one direction and again it is coming back to the same position and again after certain time it is traveling to the same position previously. Like to and fro motion, if the repetition of this type of motion within certain limit of time, then the type of movement is called as the vibration. Vibration doesn't exactly mean that in a fraction of a second the movement of the object instantly happens. That means a blade which vibrates or phone which vibrates, this is not called as the vibration. Actual definition of vibration is if the movement repeats itself within cyclic way. We can say within cyclic way within a stipulated time, then it is called as the vibration. A simple movement, let us say a pendulum or a ball which is hanging through or tied to a string and it is moving to and fro, that movement is also called as the vibration, where the movement of the ball happens within stipulated time. So let us say with the movement from one side to the other side of the ball happens in 1 second, and again within certain 1 second time it has come back, and again it is moving within 1 second to the other side, right? In this way, if this type of movement is repeated in a cyclic way, that is termed as the vibration. And vibrations in elastic body or structure are caused by disturbing forces which create a displacement of the structure from its mean position. Like we have discussed, there should be certain disturbance force or certain disturbance that needed to be created to the object in the system for the object to move. So let us say the object is moving from left hand side to right hand side because of certain force that is being acted. So this force which makes the object to move from its mean position, that is its central position, is termed as the disturbing force, and the movement of this thing happens in the system. And we can say once the disturbance is created and left behind, the object still moves to a certain distance, right, in the to and fro motion. Why is this happening? This will happen because of the elastic property of the material, where once the disturbance is created from the central position or equilibrium position of the object to one side and it is released, because of the elastic property, it will try to come back to its original position. But after that, what happens? Again, it will not take rest there. And from the mean position, because of the momentum it is having, it will again travel to the other direction. In this way, the object will try to move and to and fro motion from the mean position. So the force which is the cause for the movement of such kind of vibration is called as the disturbing force, and that disturbing force creates the movement of the object in the system. And the object will continue to move even though some force is not acting, the object is continuing to move because of the elastic property of the material. So it can be said that vibrations in elastic body or structure are caused by disturbing forces which create a displacement of structure from its mean position. The body is restored back by elastic forces produced during displacement, right? The elastic forces which will be induced in the body because of the disturbance that is created. during the displacement, these forces will be induced, elastic forces will be induced in the body. So what are free vibrations? The periodic motion in the absence of external force is called free vibration. As we have discussed, even though one disturbance is created and left behind, that means we are not applying any extra force or any disturbances once we have created the disturbance, but the object will not come to stop at this position and it will continue to move to and fro. That type of movement or vibration is called as the free vibrations. That means the periodic motion in the absence of external force is called as the free vibration. And based on mode of displacement, free vibrations may be classified as longitudinal vibration, transverse vibration, and torsional vibration. So there are three types of vibrations in free vibrations. Let us first see what is the longitudinal vibration. As shown in the figure, here the spindle, an object is connected using a spindle to the roof or certain support, and what we are doing, we are dragging this object downwards, and we are leaving it. Then it will again try to go to the mean position here, which is called as the equilibrium position, and it won't stop there itself. It will try to, because of the elastic property, it will try to move in the opposite direction to some extent. Okay, so this distance, let us say this is the equilibrium position, and we are trying to drag it till here, which is called as the amplitude. And if we are leave that object or leave that bob or any body, then what happens? It will not stop here and it will try to move in the opposite direction. And that distance is A. That will also be again amplitude. Okay. So this is how the transverse or longitudinal vibration is treated. Here what is happening? The spindle, because of this longitudinal vibration, what is happening here? The spindle is under compression and tension, right? It will be elongating and again it will be contracting. The spindle will be elongating and contracting as this object is trying to move downwards and upwards. The spindle will elongate and contract. We can say it as the compression. The spindle is under compression and tension when body moves up and down. This type of vibration is called as the longitudinal vibration. Now coming to the transverse vibration, where this object, this body is being bent or pulled to one side and it is left. Then what happens? It will come back again to its mean position and it will not stay here. It will again move to the other position until here. Then again, because of the elastic property, it will come back again to mean position and again it will go to the extreme position. Okay. So in this way, what is happening? The spindle will be under bending. As this object is moving in the to and fro motion in this direction, what happens? The straight spindle will be under bending condition. So we can say that spindle is subjected to bending when body moves side to side. Now coming to the torsional vibration, where this block or this body is being twisted, rotated. This body is rotated from the mean position. Let us say this is the top view of this figure, top view of that body, the bob, the cylinder. Let us say that as a small cylinder block plate, let us say, and this is the mean position. This is the equilibrium mean position, and it has been twisted or rotated to certain extent here until here and left behind. Then what happens? It won't come back and stay here. It will again try to move in this direction until here, right? So in this way, it will try to rotate in to and fro motion. So that kind of situation, what happens? This spindle will be getting in twisting action. So that type of vibration is called as the torsional vibration, where spindle is subjected to shear. Spindle is subjected to shear stress when the body oscillates about vertical axis. About vertical axis. This is the vertical axis. About that vertical axis, what happens? The body, as the body oscillates about the vertical axis, there will be shear stress induced by the action, and spindle is subjected to the shear stress when the body oscillates about vertical axis. Now let us understand about the simple harmonic motion. This is a special case of vibration where the simple harmonic motion is particular form of periodic motion in which acceleration of a particle or body is always directed towards a fixed point in its path and is proportional to its distance from the fixed point. Right? This is the definition of the simple harmonic motion, where the general conditions of simple harmonic motion would be a body or a particle is said to be moving in SHM, that is simple harmonic motion, if it satisfies the following condition. So there are two conditions that are needed to be satisfied by the movement of the object. First one is the acceleration is always directed towards a fixed point in its path. Okay, so let us say this is a ball which is tied to a string and it is making to and fro motion. And this is your starting point, and that we are considering as a fixed point. When the object is traveling in this direction, always the acceleration is what is happening here? Always the acceleration is directed towards its fixed point, towards a fixed point in its path, right? The object will move in this direction and this come back to its original position and go in this direction and again come back to its original position. That is the case that will happen, which is the vibration. But always what happens from the main position, it is moving in this direction. As this is moving in this direction, we can say that the acceleration is directed in this direction to the fixed point. When it reaches the maximum limit, here the acceleration would be 0, and again gradually the acceleration increases. And it will become maximum here. It will become maximum at the mean position, and again it will go to the left side direction. And as it is leaving the mean position and as it is going to the left side direction, again the acceleration will direct towards the point here. That means as it is moving in this direction, the acceleration try to decrease. Why? Because this acceleration is directed towards the mean position, and again at the maximum limit condition, this acceleration will be again 0, and it will start from here, and again it will come in this direction, and again here at the mean position the acceleration will be maximum. In this way, in a simple harmonic motion, the acceleration will always be directing towards the fixed point in its path. That fixed point will be the mean position path. Then second one is the acceleration is proportional to its distance from the fixed point. That means as the distance increases, acceleration decreases. As the distance is decreasing, the acceleration is increasing, as we have seen in the figure just now. As the distance from the fixed point is increasing, the acceleration decreases. And as the distance from the fixed point of that fixed point to the object, it is decreasing, the acceleration increases. So we can say the acceleration is proportional to its distance from the fixed point. So these two conditions are needed in the vibration to call the system or to call the movement as the simple harmonic motion. Now, the applications of simple harmonic motion, where we can observe the simple harmonic motion, is first one is the piston moves with simple harmonic motion when the crank pin rotates at uniform speed. Right? So, in an engine, there will be piston and crank pin rotation connection will be there, where the piston will be moving in linear fashion and crank pin rotates around the cylinder, or we can say the crank pin rotates around the shaft. And when this crank pin is rotating, the piston which is connected to the crank will be moving in the linear fashion. So this movement of the piston will be considered as the simple harmonic motion, where when this is happening, Always these two conditions will be satisfied by that movement. And second one is the oscillation of pendulum. As we have just seen the example, the pendulum movement will be an example of the simple harmonic motion. And the another application would be the vibration of tuning fork. You have already seen in many cases the tuning fork vibrates. So that vibration of tuning fork will be the simple harmonic motion. Then motion of spring suspended with a mass. Okay, so let us say some spring is suspended with some mass attached to it, and the movement of the mass in a longitudinal fashion, where we have seen the free body, free vibration of longitudinal free vibration. In the same case, the spring will be executing simple harmonic motion. Now let us see some important terms in the simple harmonic motion. First one is the amplitude. The maximum displacement of a body from its mean position is termed as the amplitude. Then about oscillation, one complete vibration, that is one complete to and fro motion of a body is called oscillation. Then periodic time T, it is the time taken by a particle for one complete oscillation. Okay, so one complete oscillation, that means complete to and fro motion, the time taken by the object is termed as the periodic time, and that periodic time is given as T is equal to 2 pi by omega, where omega is the angular velocity in radians per second. Now coming to frequency represented with small letter n, the number of oscillations or vibrations per second. Oscillations per second is called frequency. As we know, oscillation is one complete to and fro motion. Now coming to frequency, for 1 second, how many oscillations are happening, that would be the frequency. And this frequency is given as small letter n is equal to omega by 2 pi, which is the reciprocal of the periodic time. So that can be given as n is equal to 1 by t. So these are the important definitions in simple harmonic motion that we need to consider. Now coming to the equations of simple harmonic motion, let us consider an object that is being executed with the simple harmonic motion. Consider a particle P in the figure moving with constant angular velocity omega around the circumference of a circle of radius r as shown in figure. The projection of P, which is Q as shown here, on the diameter AOA1 is represented with Q. Let after t seconds, theta is the angle swept by the radius vector OP. Okay, you can represent the figure here, you can consider the figure, and for each and every step that we are doing, refer the figure here. Then the displacement of Q from its mean position is given by cos theta is equal to x by r, which can be written as x is equal to r cos theta. So for this system, the displacement can be represented with x is equal to r cos theta. So we can say, utilizing this equation, we can find the displacement of the particular object with the simple harmonic motion. But theta is equal to omega t, as we know it from the equations of motion, which can be written as x is equal to r cos omega t. So let us take it as equation 1. Then the tangential velocity v is equal to omega r can be obtained here. Horizontal component of v is Vx is equal to v cos 90 minus theta, that is equal to v sin theta, which can be written as omega r sin theta. But we know sin theta is equal to y by r from the triangle here, which is given in the figure. So therefore, Vx is equal to omega r into y by r is equal to omega into y. Also, y is equal to under root r square minus x square. From the right angle triangle Pythagoras theorem, we can obtain this. Therefore, Vx is equal to omega under root r square minus x square. So velocity of q at any instant is given by the above formula. From the equation, it is clear that Vx will be maximum when x is equal to 0. So we can write Vx max is equal to omega into r. Now for acceleration of particle, consider the figure here. The centripetal acceleration of P is given by An is equal to omega square r. and a horizontal component of an is given by ax is equal to an cos theta, that is equal to omega square r cos theta. But cos theta is equal to x by r, we know that from the triangle. Hence we can write ax, which is the horizontal component of an, is omega square r into x by r. Therefore, ax can be written as omega square x. Acceleration will be maximum when x is equal to r. Therefore, ax max is equal to omega square r. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.